This is the problem number 16, which is suppose A is equals to U into V transpose, where U comma V belongs to Rn and U comma V are non-zero vectors. We need to find out the eigenvalues of A, which are either n minus 1 0 eigenvalues and one is U transpose U, n minus 1 0 eigenvalues and one is V transpose V, and 0 eigenvalues and n minus 1 0 and one is V transpose U. Now moving on to the solution. Here we have U comma V both are n-dimensional vectors, and we have u in A equal to U into V transpose, which is the outer product of U and V. Now here if we carefully see, A is an n cross n matrix with rank is equal to 1. Why? Which we will see. So let U1 is of this form U1 U2 and V1 is from this form V1 V2 Vn. Then what we'll get? We'll get U into V transpose, which is equal to this into this. Okay, if we see first element will be U1 into V1, second will be U1 into V2, third nth will be U1 into Vn. Okay, similarly we can see this matrix we'll get, which is the matrix A, and A is an n cross n matrix. If we carefully see this first column, then we will see that V1, this is V1 is scalar, is multiplied with the matrix U. Okay, and which we can write this as a U into V1. Similarly, we can see V2 is multiplied with the with vector U, so we can write V2 into U, and so on. This we can write. Okay, so if we carefully look, then all the columns are just the scalar multiple of U, which means only one column is linearly independent, and hence n minus 1 columns are linearly dependent columns. Okay, which means hence the rank of matrix the rank of matrix A is equal to 1, and hence A has n minus 1 0 eigenvalues. Why? Because nullity is n minus 1. Now hence A have n minus 1 0 eigenvalues and one eigenvalue which is non-zero. Now we need to find the non-zero eigenvalue. If we carefully look A, then vector U is present in every column of A. Here we can see in every column vector U is present. So if we multiply A with U, then which we will get? A into U is, this is A, this is U. What we'll get is, we'll get U times V1 into U1 plus V2 into U2 plus order Vn into U1. Similarly, U times V1 U1 V2 V2 Vn U1. This is nothing but just V transpose U. V transpose U, which is a 1 cross 1 matrix, that which means this is nothing but just a scalar quantity. Okay, this is V transpose U, the scalar quantity. If we represent this as lambda, then what we'll get is, we'll get AU is equal to lambda U. This is the eigenvalue equation. This is the eigenvalue equation of A, where U is an eigenvector and lambda is an eigenvalue of A correspondingly. Okay, and hence which we will get the eigenvalue is V transpose U.